All right, so here's a think pair share that you should try on your own. This one I've given the answers down here so you can kind of see if you're correct. So you can continue to watch if or want to see my solution to this problem. All right, so using the data measuring the number of seconds between when the trout is hooked, either landed or lost, assume all values between and including 0 and 15 are equally likely. Answer the following questions. So what is the probability that a randomly chosen hooked trout will be landed or lost between 7 and 12 seconds? So first, let's draw our distribution. So this is going to be uniform between 0 and 15. So let's see, what's that going to look like? I can do better than that. Okay, there we go. So it's between 0 and 15. And the height here is going to be given by our probability density function, which is f of x equals 1 over b minus a. And, this is our value of b. This is our value of a. So that's going to be 1 over 15. So it's going to start here and end right there. All right. What is the probability that a randomly chosen hooked trout will be landed or lost between 7 and 12 seconds? So we have maybe 7 and 12 seconds, something like that. I mean, notice that I'm just not really being terribly accurate because I just need something to kind of represent the area that I'm looking for here. Okay. So yeah, I need to calculate this area between 7 and 12 and the x-axis and the PDF function, which has a height of 1 over 15 and starts at 0. So I need to calculate the area of the rectangle, which is going to be the width times the height. So how wide is it? Well, it's 12 minus 7 wide, and the height is 1 over 15 minus 0. Be very careful. It's not always going to be, well, it will always be 0. Okay, never mind. Let's keep moving. So here, 12 minus 7 is 5. That's times 1 over 15. 5 goes into 15 3 times, which gives us 1/3. And that's where 0.333 repeating comes from. So the probability that a randomly chosen hooked trout will be landed between 7 and 12 seconds is 33%. All right. Let's look at the next one. Part B, find the 10th percentile for the highest time a trout is hooked and landed or lost. All right, so the wording in this one was particularly to see if you're really paying attention to the details here. Because even though it says 10th percentile, it's looking for the highest time. So let me show you what that means. So I'm just redrawing my uniform distribution here. Okay. So find the 10th percentile for the highest time a trout is hooked and landed or lost. So what that's talking about is that is the highest 10%, which would be this area here. This represents the highest 10%. So what is it that we're really looking for? Well, we're actually looking for this area, which is the area of the lower 90%. So we need to find this value here, which separates the 90th percentile from the 10th highest percentile, which is up this way. So we just have to kind of do a little bit of a conversion to change a value of 0.10. We have to convert it into 0.9 and then try and calculate this value in order to get K. All right, so the area of our rectangle is going to be the width times the height. And the width is going to be K minus 0. The height is going to be 1 over 15 minus 0. And our area is 0.9. K minus 0 is just K times 1 over 15. Now we can just multiply both sides by 15. And here the 15 in the denominator will cancel with 15 in the numerator, leaving us with only K. And 15 times 0.9 gives us 13.5. So 13.5 is the fish on time, that's in seconds, for the 10th percentile for the highest time a trout is hooked or lost. All right. I think there's one more part C. So let's give this one a look. After 3 seconds, a random trout is still hooked on the end of the fly line. Find the probability that the trout will either be landed or lost between 12 and 15 seconds. Okay, so again, start with what we know. A uniform distribution between 0 and 15. Okay, that's going to have a height of 1 over 15. All right, but this is a conditional probability because we know that the fish has already been on the fly line for 3 seconds. It's already been fought for 3 seconds. So here at 3 is where the probability density function is going to start now. It's not going to start at 0. It's going to start here and go all the way to 15. So that doesn't change our value of B, but it does change our value of A. And if it changes the value of A, then that's going to change our probability density function. So that's going to be 1 over 15 minus A, which is 3, which is 1 over 12. So it's no longer going to be 1 over 15. It's now going to be 1 over 12. And we want the probability that the trout will be landed between 12 and 15 seconds if it's already been on our fly line for 3. So here's 12. So what we want is this area right here. Okay, so the area of the rectangle is going to be width times height. The width is going to be 15 minus 12. And the height is going to be 1 over 12 minus 0. So that's going to be 15 minus 12 is 3 times 1 over 12. 3 goes into 12 4 times. So the area of our rectangle is 0.25. which means the probability that a trout will be landed or lost in over 12 seconds, given that the trout has already been on the fly line for 3. That's going to be equal to 0.25 or 25.0%. All right. So once again, take home message, area equals probability. The area in chapter 5, was rectangular, but in the future sections, it's not going to be a nice rectangle. It's going to be a complicated curve shape. But guess what? Your calculator is going to take care of that for you, as long as you know how to use it. All right. Let me know if you have any questions.